Yeah, I was doing library before. I sprung 600 for a computer. So I'm at PTSD treatment at the VA Medical Center.
Okay. All right.
I went to Iraq.
You went to Iraq. Wow. Okay. Are you in Iraq now? No.
No, I was in Albuquerque a little while ago. Pretty same.
Pretty much the same. Albuquerque's a real big city with big traffic problem, if I remember right. I remember my son moving from Colorado Springs to Phoenix, and one day he planned to drive through Albuquerque, and he hit some traffic like he'd never seen before. So, so that's that. We'll go to share another screen. Yeah, I forgot to leave that recording. Maybe I should just summarize what I said on the PowerPoint for those who can have to catch it on the recording. So share back to the PowerPoint screen and share. Well, we went through the attendance, and the big announcement is this week we'll do chapter 5, and we'll schedule the exam schedule day is next week, which essentially means I'll have the exam ready next week for you, but it'll be a week-long take-home project over chapters 1 through 4, like the syllabus says. So that's the news on that. And we went through the attendance, and I made some adjustments, and now plan is to maybe look at some things on Stop the Share and look at something on virtual campus. So a new share, and the new share is my Google Sheet, and there it is. This is today's stuff. There's a quiz that you can look over. A summary of the chapter here, and is this the student view? Let's see. I think I had the student view there. Yeah, this is the student view, so it should look a bit more like this, not the instructor view. And I don't know if are you seeing that little black icon bounce around? I don't know. So overview and objectives, just a quick summary of that. Then some details here of the topics, not quite as detailed as the book, the quiz, the PowerPoint slides that I'm working off now, the Zoom link, and what we'll have, of course, after we're done, we'll give you a recording link and the marked up slides for everybody. Okay. So that's where we are on that. And what else can you see? Yeah, I don't have the next few weeks available to you. So that's where we are about getting through things. So stop the share, and I can look in on you, or at least look at the tops of your head. Huh? I did comment on somebody's earrings last week, but looks like something the governor would wear. big set of earrings on the screen. What do we? Uh, uh, so let's go back to the PowerPoint screen. This is slide here, straightforward statistics. Slides are pretty much developed by uh, J. Chen Bowen, the author of the textbook, who works at Cleveland State, where I got my bachelor's degree long time ago. So it's kind of the book for city kids, but it's a pretty decent book. I guess there were a few times when I had to explain the city kids part of it. We've got some terms in probability. An event is an outcome of an experiment or procedure. Okay, so a lot of the statistical languages was developed not so much by um, the people in the social science, but people in the experimental and laboratory sciences. So we have those kinds of things. So the terminology comes from this. This is an event. So this is something we observe in a certain sense. A simple event is an elementary event that can't be broken into simpler pieces. So if you would like roll a standard die in its standard usage, an event would be getting a 1 or a head on a coin flip. Sample space, a complete list of all possible outcomes. The probabilities of all possible outcomes add to 1. Okay, well, we haven't defined probability yet, but sort of an early emphasis of that. So notation for probability, P stands for probability in this book. A or B stand for particular events, and sometimes they'll use a C or a D too, but often that's the way things go. Probability stands for the probability of event A happening. So examples in the textbook, if you give birth and it's a girl, the probability of, they would use a G there, probability of having a girl, roughly 0.5, although that isn't quite true. Probability of A is the number of ways A can happen by the total number of all possible events. So this is somewhat a easy way to think about probabilities and doing calculations for things like card games and casino games, or selection kinds of rules in quality control. It also will help you in sampling, but the more general idea of probability is if we can like partition something, the partition in age group, what proportion of the population are teenagers from 13 to 18, or minor teens might be your interest. And you could go look at every person in a certain area and count the number and look up their age. So probability of A is equal to 0 means the event does not happen. Okay? Just doesn't happen. Right? So you may think of these things that are structurally this way. You know, or rarely. In Maryland, you can't own a car unless you have a driver's license. They just don't let you. That doesn't seem to be the wisest kind of thing, but at least at one time that was true. So it has to be registered to someone with a driver's license, at least on an initial registration. I suppose if you were to have your license expire, your car isn't confiscated, but don't know for sure. And probability that of A is equal to 1, it means that an event definitely happens. Okay. This is the certainty. And this is a lot of times just the practical things. You know, in a true coin flip, we either get a head or a tail. And the probabilities are between 0 and 1 inclusive. Now, what this means, it's actually if you are in a situation where you can assign or guess a probability, you have to guess between 0 and 1. If you do a calculation and you get a negative number or 1 greater than 1, it's wrong. Okay, so if you do a calculation and you happen to get something outside the range, you'll get it absolutely wrong. I did a calculation on a test, and I got a negative number, so I commented that something must be wrong, and the instructor wrote back, "This is my mistake. He set up his calculation incorrectly." Yeah, so I think that might have been like my first or second test in grad school, though. Now, procedure with 2 possible outcomes. This might actually in possibly a later edition of a textbook, this kind of thing might change. It is a bit insensitive. The probability of having a girl and the probability of having a boy at a single birth. There are a couple of things wrong with this assumption. One is there are people who are born somewhat intersex, and you might not be truly able to assign this. So there's this kind of coin flip kind of thing is an simplification, which might be viewed as insensitive, but it's a current simplified way of looking at this. Although my birth certificate has a rather strange indication for sex. I think it was actually filled out in a handwritten manner, and I could see somebody new in the office may have asked how you spell the word male, and somebody answered M-A-I-L. That's what's on my birth certificate for my gender. I don't know. I suppose if I was in North Carolina and they required me to use the the restroom of choice, the person at the hotel might wonder about what I'm going to do. So boys and girls births, uh, one half, one half. Although this isn't actually, there tend to be a somewhat more males born than females usually. So it's more like 51-49, but just a simplifying assumption. Um, uh, and the probability of boys plus the girls is equal to 1. So just a simplifying observation. So the sample space includes 2 simple events, and they're mutually exclusive, and they add to 1. So probability of having 2 children, um, let's see. A woman could have 2 boys, a boy and a girl. The boy could come first, or the girl could come first, or we could have 2 girls. So the simple events in the sample space are BB, BG, GB, GG, and each has a quarter probability. So those are rules of simple events, and they all have to sum up to 1 if they're mutually exclusive. The occurrence of one event doesn't impact the probabilities of other events. Okay, that's what we mean by independent. Now, sometimes it's easy if we're doing something like flipping coins. And we have a fair coin. Our history doesn't matter, and it's kind of clear, and it's a good assumption. Other times, for example, how long you spend waiting in a line has a whole lot to do, is not independent of how long the person in front of you spends waiting in the line. Okay. And generally, the sex of the first child doesn't impact the probability of the sex of the second child. Usually we make that assumption. I haven't seen that verified, but that's a usual assumption. Multiplication rules for independent events, probability of A and B occurring is the probability of A times the probability of B. And that's what we mean by independent events. The intersection of both, and it's kind of curious. We could go back here, and the probability of, for example, BB is the probability of B on the first times the probability of a boy on the second, and then that'll give us a quarter, just like we were looking for. Mutually exclusive events, which means the 2 events, event A and B, are mutually exclusive. Only one of those can happen at a time. They cannot both happen at the same time. No. you're either in the city limit, inside the city limits, or outside the city limits. So you're either in town or you're out of town. Um, um, in sports, for example, uh, um, you're either in bounds or out of bounds, and there are rules for that. Mutually exclusive events, and that's what we mean by the term mutually exclusive and disjoint events. You may have seen these things before, but the term for this kind of drawing, where we look at circles or squares and look at overlaps if two things can happen at the same time, are called Venn diagrams. And this is the Venn diagram for mutually exclusive events. There's no overlap of A and B occurring. No overlap whatsoever. Either you have a driver's license or you don't. Okay, I mean, you're single or you're married. When event A are mutually exclusive, the probability of either event A or B is the sum of the probabilities. So the probability of A or B is A plus B under mutually exclusive. Now, we can actually make use of these. These two events are mutually exclusive, right? BG or GB. So you either had the girl first or the boy first. And however, the probability of BG can be calculated because we know we believe it's independent whether we have a boy or a girl at a birth. So PB times PG is equal to 0.5 times 0.5 is 0.25, and therefore the probability of having one boy and one girl is 0.50. And my wife and I have two children. And at least that's what we believe. And our oldest child is boy, but he's 30 now, and our younger child is a girl, and she's 27 now. So I'm old. Of course, being taught by some grandpa. Okay. We have sort of a generalization of this coin flip or having births, and it's called a binomial distribution, and we'll talk a bit about this. However, I won't actually make much emphasis of this, and some of the notation we'll kind of skip over. So the procedure has a fixed number of trials. Okay, for example, we may flip 5 coins, or a woman might have 2 children born. But we fix the number of trials, how many times we flip apart, or if it's 11 in the morning for me, very often we'll talk about sampling a production part out of a lot of manufactured parts, and we want to check to see if they're they're good or bad, and our procedure will say to pick a certain number. The trials are independent events, which now makes our coin flips or our selection of parts, if they're defective or not, pretty reasonable. We may, if we work very carefully and we selected individuals in a community, we could independently, with a careful adjusted random procedure, we could ask about their political affiliation among voters, or their but the probability of outcomes in one trial doesn't affect the probabilities of outcomes in other trials. So easy to see in like card games, or well, not in dice rolling. So there are only two possible outcomes for each trial, success or failure. The probability of success and the probability of the failure stay the same in all the trials. So this is what goes on in the binomial distribution. Well, S stands for success and F stands for failure. Probability of success in one trial, in a coin flip or in a coin trip situation. If we were seeking ahead, that would be the success. In the childbirth situation, out of convenience, we would describe a person of one sex as a success, and out of another, just to get it in our formulas. Not to say that one sex is better than another. So probability of failure is 1 minus p. Complement rule, the probability of failure in one trial. N is the number of trials and R the number of successes. P of R is the probability of getting exactly one success in a trial. So how do we go about calculating this? Well, we can stop the share, and where would you go to do this calculation? And we can talk basketball, maybe. Where will we go? We can stop the share, and we can start a new share. We can go to Excel, and I think I have Excel open. Do I have Excel open? No, I had it open. Oh, where is it? Basic, advanced. Where can I share? File Explorer, PowerPoint, Zoom. Maybe I'll just share the screen and pop up the Excel. Share the screen. I guess I'll need to escape this. Okay, that's where we are in the PowerPoint, and I'm sharing my screen. There's Excel. Somehow it didn't show up. So if we start out with Excel, what can we do to calculate that? and we need N, we need P, and we need R. Um, and view. Oh, okay. I guess I'll have to bounce out of here. Zoom. Maybe we'll go to 200% to give you a little better viewpoint. So Zoom NPR, and let's say we'll talk basketball. How many free throws does somebody get to shoot during a game? What do you think? 3, 5? Somebody want to put it in the chat? What would be a good number of free throws in a game?
5.
5. Okay.
I think I
5.
seen Shaq do. Yeah, just kidding.
How many did Shaq do? I could see in certain situations, and Shaq was playing, you just put in people to foul him. Just to okay. The probability of somebody making a free throw, what do we like? For me, it's kind of small, right? It'd be what, about 0.3? I don't know. I haven't shot a basketball in a few years. What do we like? Maybe 0.9? Okay. 0.9, fairly good free throw shooter. What we talk, maybe a 90% free throw shooter, pretty good free throw shooter. In R, what's the probability of making 4? Okay. What do we have? In Excel, we have a function equals B I N binom dist. And we can put it there. And number of trials is what we have, 5. And comma. And then, oh, okay. So the number of the result is 4. And the trials are 5. And the probability of making it is 0.9. And the probability distribution and false is the probability mass function. So this is just a single result. If we say true, we get the cumulative. So we need to type false. And the probability then of making exactly 4 out of 5 is for a 0.9 free throw shooter is 0.3218. We can also look at the similar problem, 4 or fewer shots. So equals binomial dist, and the number, then 4. and trials 5, and probability then of making the shot 0.9, and we then comma true would give us the cumulative. So which then is all the numbers, probability of a 0, the probability of 0 shots made, probability of 1 shot, probability of 3 shots, and the probability of making 4 shots, all summed together. And so that's going to be a much bigger number, right? So so the probability of not hitting 5 out of 5 for 90% free throw shooter. What will we guess that to be? Not hitting 5 out of 5 for a 90% free throw shooter. Oh, maybe about a point 0.95 or something. We'll see. 0.40. Whoa. What's the probability of hitting exactly 5 out of 5? Probability binom dist backspace 5 comma 5 trials comma 0.9 and comma false. So probability of hitting exactly 5 out of 5, point 0.59 for the free throw shooter there. So that's how to calculate a binomial distribution in Excel, and we can work through this in the same manner. We might want to also, and I'm sharing my screen so we can go back and look at Google Sheets and view. We can come up and make it 200% also, and it has equals BINO. It has a binomial distribution too, and it works pretty much the same way. Let's see, probability false by default, whether it's cumulative or not. So we have the same system, same setup, the same function is available in Google Sheets. And of course, the reason for this, I'd like to mention it, to get to Google Sheets, you just need to have a Google account, and that doesn't really cost you anything directly. But to use Excel to do the same calculation, you need to find some legal access to that. So you might be in a situation where you need to work with Google Sheets. So if you want to do calculations with regarding to the binomial distribution, you can. And we also realize that there's um, binomial binom dot inverse function too. So if you have to answer questions of what is the given a probability of what number of successes would I need to have, and you have to be a little careful reading that. So there are binomial tables in a number of textbooks, but it's generally more convenient to get on a spreadsheet and apply the functions, especially if you have to do a good number of them. And you just sort of have to remember the name to get to that, and know how to use the help functions in or web searches to get answers on that. Okay, go back to the PowerPoint. And so we have the answers here. NPR, like public radio, National Public Radio. I know I might, somebody might be driving and listen to me instead of listening to NPR while they're traveling. So slideshow from the current slide. Now, there are some formulas for doing this, and have to learn some difficult, some notations, and then you have to also learn how to make use of this term here, combinations, and you have to learn how to do these factorials. It can be fun if you like doing hand calculations with math. Just remember that it's much easier to do these calculations of probabilities with Excel or some other computer program for binomial probabilities. I know I usually mention that binomial, Latin word for two is bi, and nome is Latin word for name. So anything that can have two names, success or failure, or two categorizations, we can look at for binomial distribution. You can calculate the mean of a probability density function by x times px and add them all up as the mean. If we designate a head as a 1 and a 0 as a failure, our average number of coin flips is, with a fair coin, is 0.5. We might like to think about this as in sports, like calculating a batting average or free throw percentage. The number of our slugging average might even be a better thing to think about. You know, if you're a baseball stats person, slugging average. And then there's a formula for getting the variance and the standard deviation of these distributions, and we can apply the formulas. And then for special distributions like the binomial, they're just straightforward things. So the mean, so this, remember these symbols are where's my pen? Okay. This is mu for mean. This is sigma squared. For variance. I don't know if the social sciences, you know, throw out the sigma squared very often or say variance more often. Quality control guys usually throw out the sigma squared. And this, of course, is sigma. For standard deviation. Okay. And we have these simple formulas, so you don't have to go through and look then at the special cases to get the long way of going about finding those. Here's calculation, the probability, mean and variance probability distribution of number of girls in a family of 3. So number of girls, here a success is having a girl, okay? And the probability of having each of these 1, 2, in 3 is just given, and we could go through and where's my we could go through and verify this. So with in Excel, so maybe we should do that. I have to escape this. Yes, I'll keep it. And we can pop up Excel. So we'll go binom dist, and we'll have probability of 0, comma 3, comma 0, comma 3, 0.5, what we've assumed, and the cumulative equals, we want just the mass function, so false. I guess they like all the caps. I don't know if they'll let me do that. And let's see if we get the 0.125. So yeah, so we could go through those and generate that the same way using Excel as our binomial calculator. Go back to the PowerPoint and from current slide, and then we XPX, and then when we total them here, it's the sum of XPX, and it's 1.5. So if you have 3 kids, on average, you'll have 1.5 girls. Now we'll take X minus mu, which we have there, and calculate it, and X minus mu squared, and you square this number here, and x minus mu squared times p of x, we can go through and calculate 0.75, and we can justify this. So our definitions in this special case for this particular distribution can be used by the formulas derived from the binomial distribution. So those are straightforward. And should we do this in Excel or Google Docs just to maybe we should look at that. Okay, and let's just pop up Excel and add a sheet here, new sheet, and view zoom to 200% so we can see that a little better. And we have X, the number of girls, and PX, the probability. And then we have X. Maybe we want to use the multiplication sign to show a little bit more XPX, and then so those were our labels, and then open X X minus, and we do have the space. Let's see. There is a way to make a longer minus sign, except I don't remember offhand how to do that. We can go back to the home and we can change the font. And if you go to a symbol font, you get the, oh, wrong Greek letter. I have, oh, no, it's an M. Okay, so select the M, and we go all the way down and grab up a symbol font. Symbol with all the Greek letters. You can get a cute mu just like in the textbook. And then we can copy this. And then we can use sort of the math function. Like here, we can get get back in. There's my caret 2. And then Control C, Control V, just copy that over again. And then go back. Times, maybe we'll need to widen that cell a bit to show. We might want to center all these, make it look a little neater. And we have 0, 1, 2, 3. Center those. And P of X. Remembering it was point 1, 2, 5 or 1/8, and then 3/8. Point 375, and copy that down, and the point 125. Those are our numbers. And then we can go with X times PX, like that, and we'll get 0, and can drag it down. And then we can let this be our total. Maybe put that on the right side. Oh, no. Format to the right. And then we can sum this, and this is mu, and we can auto sum that. So click the auto sum button, and 0.15, same answer we had there, equals X minus mu, and we'll need to anchor at least the row here, and anchoring it with a $sign is a helpful way of looking at it. And we might want to anchor both just to be careful. 0.15. We can drag that down and do all those calculations, and then we can square this. So just raise it to the 2, or you can multiply it by itself. Which is just squaring what we had there. What? Oh, yeah, that shouldn't be a caret. That should be a multiplication sign. We can't raise something to a negative power in this class. So we have our squareds, and now we just multiply this times this, enter cell, and we can drag that down, and then we can sum this and get our variance. And then an auto sum. Enter 0.75. So that table, as we can see, matches up with the table in the calculations there. So doing those table calculations are not too difficult when you have a spreadsheet, and you can add the mu and the sigma. So the sigma is actually an S. Okay, so we went through this and saw how to do that in the spreadsheet, and remember going through that. And if you go through and do the calculations, oh, got a chat message. Did have a chat. It's not showing my chat. I'll have to stop my share to see my chat. Okay. Okay. Joel, might go back and check that attendance. And okay. And Stephen, okay. I stopped the share, and I realized that I don't know if I have Joel marked present. Okay, I don't. I'll do that.
Do you have me, Frank? This is Brittany. I just got on about 15 minutes ago. I got off work at 6.
Okay, I don't think I do. Right, Brittany. Anybody else? Joseph, Kimi Mila, Brad, Sherry, Justice. Okay. Yes, we can. Oh, I should. What do I do? I have to escape and keep. And so I just mark the attendance, and I can go back to Zoom. My Zoom. I'm back here. And now I can share my PowerPoint. Okay, and from current slide. Or maybe it's better to sort of search through where we are to, we were here, and then from current slide. Okay. And yeah, those numbers you can go through the formulas and it's faster, and you can go through the tables for the binomial. There's something that we've looked at a bit, and there's addition rule of probability. What's this? I don't. Addition rule of probability. When event A and event B are not mutually exclusive, the number of either event A or event B both happening is the sum of the event minus the overlap of the two. So probability of A or B is probability of A plus the probability of B times the probability of the intersection of both. So this U is for union, this N is for intersection. Okay. And sometimes there's a union street and it has intersections. Okay. Do we have a union street? Rapid? I don't remember. There's a city, a small city near where my father grew up called Union Town. Yeah, there is. It's in southeastern Pennsylvania, not too far from the West Virginia borders. Okay. So much for Eastern geography. Don't want to talk too much about West Virginia. So I guess I could write this. This means union. And this means intersection. In case it's been a while since you went through this in school. All right. So probability of event A, getting a 1, 2, or 3 is 0.5. Probability of getting event B, a 1, 3, or a 5, this might be like a dice roll, is 0.5. The overlapping probability of events is getting 1 and a 3. So the probability of the intersection of those in a dice roll is 2/6 or 0.33. So the probability of A union B, one or the other, is A plus B minus the intersection is 0.67. You know, these calculations end up being a little easier if instead of a cubic die with all the strange decimal places, you get tetrahedron. Imagine this, a pyramid with a triangular base. Okay, and you can make those symmetric if you want. So, the probability of throwing a die to get a number smaller than 4 or an odd number is 0.67. So a number smaller than 4 or odd. In one of those sets or the other. So one way of saying that, not getting a 4 or a 6. So that's addition rule of probability, and we'll use that somewhat sparingly. More often, we'll go through and use this. What was this? First addition rule is the more common one for us. However, this second addition rule is the more general case. Probability distribution tables, requirements for constructing a probability distribution table. Variable X, is that somebody entering? Check the chat window. No. If you're entering and I didn't mark you on the attendance, I can go back and get that. So got a chat. Where is the? It's not showing my chat. Okay. Stop my share and go to my chat. Okay. All right. Is that okay? Did get a chat message from Steven, and he's waving and he's on 2 screens, and so good to actually be home, huh? Right, we can go back and share again. Share the PowerPoint, and did I get Steven? I guess we can. We can go back. This must look really bad on the video. Did I mark Steven here? Yeah, okay. Constructing probability distribution table. We need X as a discrete numerical value, and the number of possible values of X is finite. Each value is associated with a probability, and each value needs to be, it's a probability, so it has to be within 0, 1, expressed that way. The probability of every value has to add up to 1, and the way we say this is summation. The probabilities of X is equal to 1, and this is the uppercase letter sigma, but we often just say sum when we see it. Now there's also a Z table, and you can find one in your textbook on page where's the Z tables? Z table is on page, it's like 500. Oh, 495 and 496. Z table, standard Z table. All values are reported to 2 decimal places. Column Z tables. Let me see. I think I have one of those. Escape. Stop the share. And I think I have a Z table. Go look for that. Okay, spring 18. Oh, okay. Okay. Yeah. Last time this is page 495 in your textbook, and view zoom to 200. Okay. So this is how the Z table works. 0, 0 is 0.5. Okay. So this is our normal distribution we talked about last week. So the probability of we're doing probability of less than Z, less than 0, to the left of Z in the Z table is 0.5. So that's 0, and then we add the other 0.0 here to get 0.5. And if you remember, we had about 95% between 2.0 and so this then works out, and that would be about 0.975, because you have 0.25% on the left and 0.25% on the right, and so forth. So that's one we're familiar with. Actually, the number closest to the 0.975 is 1.9, this row, and this column for the 0.95 here, 0.975. So those are ones that we know, reading from the edges to the center of a Z function. So this is a table that is, am I sharing this? Zoom, Zoom, share screen, share. Okay. This essentially is page 495 in your textbook, and this is how a Z table works. You remember we had 68% between the 1 sigma limits, so 0.5 would be from 0 to negative infinity, and 0.34 would be from 0 to 1. So together, the 0.10 is about 0.84. So that's what we have here. This is the 0.84. We get the 1 here and the 0 here. So 0.84 is roughly what we'd have for those calculations with the Z table. Go back to the PowerPoint, and we have that Z table up. PowerPoint slide. Okay. So we can check the comments. Z's are reported to 2 decimal places, and the probabilities. Column Z values to 1 place after the decimal point represents Z. So the probability that Z is less than a given value is what's in the Z table. So it's the area to the left. If we have a problem with the area to the right, we just do 1 minus. So it's what we need to know. And there's an example here. What is the probability of a cholesterol level less than 1.73 standard deviations above the mean, expressed as this? So it would be probability greater than that. And there are two ways to go about that. Okay, so this is just a general drawing from using the left tail. So less than 1.753, we can go and escape this, keep it, and look at our Excel table, 1.53. So here's on page 495 in the textbook. You'll go to 1.5 here. So along this row, and then 0.3 along this column, and 0.937 is our answer. You can maybe copy that and type it. So you could do that. And now we can go to the PowerPoint and from the Z table, 0.9370. So this time, no additional calculation. And we looked it up from the Z table in the textbook, and I have I built those Excel tables to kind of look like the same as your textbook. The fonts might be a little different, but 1.5, 0.3, 0.973. What is the probability? Okay. What is the probability of scoring higher than 0.178 standard deviations above the mean on an SAT? So a mathematical way to express the probability of a score higher than 0.78 standard deviations above the mean is probability of Z is greater than 1.78. And to do this, you have a complement. You have a complement rule is what's recommended. However, there's actually another way to do this. It's a symmetry rule. And we might just, do I want to show you that? I'm just thinking when I've taught this sort of in a classroom, there's another way to approach this, and let me just write what do I, this is actually okay. This is actually equal to the probability that Z is less than negative Z. Okay, so there's two ways of solving this problem. One on page 495 and one on page 496. So what we have here to solve this is by this method, we then go and have one and look up a number. I guess I can escape this. And am I sharing the screen or sharing the PowerPoint? Stop share, share, share screen. Okay, I'm sharing the screen. Can go look at the Excel and 1.78. So 1 and the point 1.7 and the 0.8, and then we get 0.9625. Okay. 9625. We can go back to the PowerPoint and 1 minus 0.9625. Nine, 6, 2, 5, and then that then, of course, would equal 0.00375, right? That's, of course, one way to look at the problem. The other way of looking at this is the probability of that Z is less than negative 1.78 to solve the problem by symmetry. And the symmetry rule, you remember, what's the same on the left-hand side as on the right-hand side. So if we want this area here by symmetry, we can go and check here at negative 1.78 and get the answer. So can escape, keep, and go to the Excel and this table on page 496 in your book, and zoom 200%. We can look at the negative 1 point. So negative 1.7 and the negative 0.8 and get the 0.375. Okay, so we have that directly. And can actually copy that little box and go back to the PowerPoint and say home, insert screenshot new slide. Text box, we can insert a text box like here and Control V and get the 0.375 in that text box. So we can copy things into PowerPoint. cutesy stuff. Okay. So can insert a text box and go back, slideshow from current slide. So you can actually, if you have a table like that, and then I guess I could put that Z table on your on the week's website references. You can. It might be easier than flipping back inside the textbook. So that's another slide. I usually put numbers on my slides. It gets a little strange when I'm not. So what's the probability of being within a half a standard deviation from the mean? And so if you look at the graph and follow this, that's perfectly all right. And I do think that's what Dr. Bowen had intended. So we know the area from here back is 0.6917, and the area from here back is 0.308. So we just have to do this subtraction to get the answer. You can attempt to put these two terms in the equation, but if you can follow the graphical discussion and the text, this is perfectly reasonable. And you know, to do that calculation, you use a calculator or a spreadsheet or the calculator on your laptop. Let's see, transform raw scores to z-scores with the same formulas we had last week. Use the z-table to connect. If we have raw scores, we can go do a problem like we did last week and create a z-score, and then connect the z-table to probabilities. So this is really a tremendously helpful thing. If we can assume our distributions look a bit normal, and we can use our z-scores, we now can look things up in tables and find the calculations. And you can do that with a table. There is something else. Don't know if I showed you this. Yeah, no, I don't think I did. We can use Excel, and the same functions exist in the z-table is actually in Excel, so I can escape, and we can pop back to Excel and just our general Excel page, and equals NO and Shift O R M dot S. It's not a dot. It's a dot Shift S. Okay. And I could just note here, it's a little sloppy, is the Z table edge to center. Okay, just as we've been using it. So that function is there. Okay, you have too few arguments, so that's not good Excel to make that note. But there is an Excel function. Oh, is it going to let me out of there? Are you trying to type a formula? Okay, not good Excel. So that's not good Excel. So Excel doesn't like that. But there's also dot S dot inverse. And this is the Z table center to edge. So reading it backwards is what's in, and again, that's not good Excel. But it wouldn't be such bad PowerPoint. Just mentioning that. And we then can connect those from current slide. Okay, so a little bit more challenging problem. College only accepts students with ATC composites above the 80th percentile, assuming that the ACT scores are distributed with mean 21 and standard deviation 1.45. What is the composite score required to get in? So there's that additional formula that isn't used very much in the textbook is, but I like to do it. X is equal to Z sigma plus mu. And now we just have to find the Z value for the 80th percentile. And we then can look up what the Z value for 80th percentile. We need to look that up. So we can, I guess I can erase that. So what is our Z value for the 80th percentile? z-value for 80th percentile. Equals, and we just need to find point, can escape. Yeah, I can keep those. And we can go to our Excel table, the way it's done, and go to page 495. What I do? Page 495, because it's greater than 0.5. And we just search on page 495 for the number closest to 0.8. What's the number closest to 0.8? It's 0.8. This is the closest one, the 0.7995, and that's 0.840. So this row, this column gives us this, and our result is 0.84. And we can go back to our PowerPoint and I guess I can do this. This is a little sloppy. Shift enter. 0.84 from the table. Let's drop the Z. So we can get that from the table. There's another way to go about getting that. We have an Excel function. Actually, we were working with it before. Norms.inverse, and we'll have 0.80. Norm.s.inverse in Excel, and I believe it's in Google Sheets 2. So 0.8416. So I'm gonna pop over to PowerPoint and enter, and tab, oh, table. Control V. In Excel. Okay. So you can use Excel like a table, and it also works for Google Sheets, and that of course could be real helpful. But we still don't have our answer yet. We'll need to pick up our calculation. So we got the have the 0.84, and then we just need to multiply it times the sigma and add the 21 to get our answer. And I guess I can escape that, and I can pop up a calculator. And we can just multiply that through 0.84 times 5.4 and hit the equal, and then add plus 21 equals does this let me copy too? Okay. 25.56. So you have to get at least a 26 rounding up. I guess I have a drawing tool here. Don't I? So I need to get a 26 on the ACT. Okay. I get a ruler too. All right. All right. So work through that problem. Here is just the way I did it with Excel with table lookup, and this was the solution Dr. Bowen put together here. So you have to get a 26, and she used a different formula and did the algebra to get the answer. So if you like doing the algebra and remembering one less formula, that's how to do it. And did she mention the Z formula? Here they mentioned was formula to use the Z formula, and we have the other solve portion of it the way I like to do it, and I gave you in class last week. It's getting near 7. Probability and raw scores. Adult women's BMIs, body mass index, are mean of 27.1 and standard deviation of 6.5. What are the low end and high end of the middle? 95%. We can play around with this a little. and then realize the left tail has to be 0.25, and the right tail has to be 0.975, and that works out. And we talked about that a little earlier when we discussed that. It's 1.96 is what we're looking at. So 1.96 is what we got off the table, and of course you could use the norm dot s dot inverse for either of those values, the 0.12, 0.025, or the 0.975, and it would give you those answers. Table lookup. 1.96 is what we can get with a table lookup, and here she did the algebra. She does the algebra at every step here. So body mass index of between 14 and 39, high end and low end answers. And I'd just like to note, you could use the formula. X equals Z sigma plus mu, where Z is, for this one, negative 1.96 times the sigma, which is 6.5 plus Z, which is 27.1. Okay, so that's also another formula. And then similarly here, you could use that to get those 95% intervals in raw score. So this is the end of the slides. Went through that. Let's maybe look at something else. I guess will you will be given a take-home exam next week. Over sections, over chapters 1 through 4. And I'll hope to have all your homework back by then. Do like to, so we can so escape, keep, and might want to go back to the first slide. Yeah, sharing my screen. I can go weed. Okay. Um, doesn't like that. Google Docs doesn't like it. Google Docs also has equals, norm, dot s dot inv, also just like Excel. And it also has yeah, equals, and um, does it have norm.s.dis too? So it has the same Google Docs. And you can do like a web search on Google Sheets, especially if you use a Google Chrome, right? And it helps you give some like a help function in Excel. Go back and look at what we have for your assignment this week. You have two things to look at. You have a quiz, and then an assignment, much like last week, where you work through the learning assessments. So we can let you do that. We'll have you skip some of the problems though, and that's that. Next week, you'll get a take-home exam, and I'll give you some advice on that, and that'll be most of the session, me giving advice on the take-home exam. We'll go, and I guess I can go back to Zoom. What do we have? Chat message. Oh, I have to stop my share to see my chats. Okay. I just I was just a private message of why somebody was cutting out. Uh, uh, yeah. Our my observer has already left too, so I I didn't watch. Oh no, you're still there, Connie.
Yeah, I just didn't turn the light on. It got dark up here.
Oh, all right. Yeah. Sometimes the observers cut out early. I don't know if I should tell on the other faculty, but I've had observers kind of leave during break time.
Yeah, we can do that. It's always fun to review my statistics. So thank you for allowing me to join all of you and keep up the difficult, challenging, but good work this semester. And I'm sending you an email right now, so you can, if you have any questions, you can ask.
Okay. All right. Yeah, I know you guys usually fill out the forms while you're waiting. So, all right.
Started but not finished, and so I'll send it tomorrow.
Okay. I guess I'll have that to look at, and so that's as you probably know, other students. It's the common practice at OLC to observe the adjunct faculty as just a matter of their quality control, accreditation kind of paperwork, and it's one of the more common ways of doing it across academia overall. So this is nothing unusual, and I guess the first time I got observed in humanities and social sciences, I got to joke around with folks at the School of Mines. I said, you know, I always thought I was kind of a weird guy, but they sent at the other place I work in my part-time job there. They sent a anthropologist to observe me. But so I didn't know I was that unusual. So
Well, in all technicality, I'm a criminologist, so there you
oh
go.
well, now I should be more scared. They said the criminologist this time. Okay. All right. Well, but the first time it was yeah, anthropologist. Now a criminologist observing me. I might need to hide my street address then. And see what laws it. So I could see maybe this will come up a little more legalistic than the last observation. Okay, let's call this a night then. Um,
Frank, I had a question.
okay.
This is Jermaine.
Hi.
If we get stuck on our homework, are we able to email you or?
Yeah,
Because there's no tutors for this class.
Okay. You can call me or email me. My phone number's in the syllabus. I'll probably get back faster on a call than an email.
Okay, and then did I hear you correctly where you said you would be logged on at 4 if we had any questions prior to class?
Yeah, I was logged on at 4 this week. And on the second and third week, I started the wrong account on the wrong last week. I tried to log on, but I realized I'd started the wrong Zoom session. So I
Okay.
actually was on for last year's class, which is kind of weird.
Yeah, because I did have a couple of questions. I was trying to get home early to get on there. Just then I left my jump drive at work where it has all my Excel spreadsheets in there.
Okay.
So maybe sometime within this week I'll send you an email or something for a little more clarification, because I watched the videos that are in the Moodle there, but for some reason I wasn't catching it, you know. So
Okay.
so definitely I will send you a email to get some clarification, and then once I have that, I'll be able to submit my third week homework. And then
Okay.
I started working on chapter 4's homework too, so I should have those turned in within this week too.
Okay.
So
Sounds good.
okay. All right. Good night.
Okay.